Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question which is based on the AC voltmeter and ammeter connection based numerical. Okay, so the question is in the circuit shown below. In the circuit below, M1 is an ideal AC voltmeter. So this M1 is a ideal AC voltmeter and M2 is an ideal AC ammeter. Okay, the source voltage in volt is vst equals to 100 cos 200 t. Okay, so here we can say simply the omega value is given 200. Okay, 200, simply 200 we can write, and the am value we can say the amplitude and angular frequency is 200. Okay, clear. The source voltage in volt is AC source voltage in the volt is VST 100 cos 200 T. What should be the value of the variable capacitor C? We have to find the variable capacitor C such that the RMS reading on the M1, that is our voltmeter, is 25 volt, and M2, the ammeter, ideal ammeter, having current 5 ampere respectively. So we have to find the value of C. Option are 25 microfarad, 4 microfarad, 0.25 microfarad, and option D insufficient information to find C. So first of all, in this circuit, M1 is given, that is our voltmeter, gives 25 volt, and M2, the ammeter, gives a measures a current of 5 ampere, and there is a variable capacitor. So we have to find the particular value of C during which this gives the 5 ampere current will flow, and the voltmeter that measures 25 volt, and this one is 5 ohm resistance, and inductor value is 1 henry. So for this purpose, what I am doing, we can say the this thing, we can say simply I am taking this one I am saying is considered as a impedance, say Z. I am considering this as a impedance Z. So if we modify the circuit, and initially we are thinking only about this part. Okay, we are thinking about this part of the circuit. Okay, this yellow part. Okay, so if we redraw the circuit for this part only, what we will write, or what we will draw, we can say there is a voltage source having 25 volt, it is our M1, and the current that it gives, current is flowing 5 ampere. Okay, and this current will go through some impedance, that is our Z. Okay, so this one is 25 volt, 5 ampere, and this one is Z. Okay, so I am saying this one is V, and this I am saying I. Okay, and Z. So we can write it V equals to I Z. Generally we are writing V equals to IR, but impedance, because capacitor and inductors are there. So from this point we can find the value of Z equals to V by I. Okay, and this V by I value will be, so Z equals to V is 25 volt and I is 5 ampere. So the impedance value will be simply our 5 ohm. Okay, so the impedance value is now 5. Okay, I'm highlighting this one. Impedance value is 5 ohm. Now it is now clear, 5 ohm. Okay, so in this circuit, this one is a AC signal, some linear time invariant circuit, and it measures a volt 25 volt and 5 ampere current in the circuit for a 5 ohm resistance and 1 henry with some capacitor value. So capacitor value. So now this Z consists of series combination of this Z, this Z. Okay, is nothing but simply we can say a series combination of resistor and a capacitor and an inductor. Okay, so I am saying R, C and L. So for this one R is there and this one is 1 by impedance 1 by SC. Means if some capacitor is there, the impedance we can say ZC equals to 1 by SC, and some inductor is there, in the impedance value is written as SL. Okay, so this one is 1 by SC and this one is nothing but simply SL, the impedance term. Okay, the impedance value, not we can consider this one. Okay, so this 1 by CL or 1 by, sorry, 1 by SC can be written as, okay, I'm writing 1 by SC, the impedance value. This one is R. Okay, we have to take R 1 by SC. So 1 by SC J omega. Okay, and one can also write this as a J by J into J. We are multiplying numerator, so J by J square omega, or what we can write minus J. Okay, J square minus 1 omega. Okay, C we have to multiply, sorry, C we have to multiply. So minus J omega C. So it can be written as minus J XC, where XC goes to 1 by omega C. Okay, is it okay? Clear? And just the impedance value 1 by SC. So 1 by omega C, S equals to 1 by omega C. Then after multiplying J in numerator and denominator, and after solving this one, it will finally come this one minus J omega C, and this should be written as minus J omega C, where XC equals to omega C. Okay, this one is the XC. Okay, equals to, sorry, minus XC minus J omega C. Clear? Now this impedance for the inductor part, the impedance can be written as Sj omega L. Okay, and this can be written as JXL, where XL is nothing but simply, we know the basic, but I am just highlighting the thing. Okay, and let me different color. SL for the inductor, S J omega, J omega L, and we can write it JXL, where XL is omega L. Okay, RLC. So once again, so the basic, okay, first pencil, then this can be R, C and L. One can also write directly, if you know the direct, this can be written as minus JXC and this should be JXL. So the equivalent impedance can be written as, this should be R minus JXC plus J omega JXL, sorry, omega no, XL. Okay, or simply we can write R plus JXL minus XC. You can directly write also, but how we have to write that I will show you. Okay, XL minus XC. Now what we have observed that this Z value is 5. Okay, so this 5 goes to R plus J XL minus XC. So this Z value is 5 and this, there is no imaginary part, so 5 into J into 0 we can write. So R is nothing but simply 5. Okay, so XL minus XC equals to 0. So one can write XL is nothing but XC. Is it okay? XL is XC and R value is 5. So Z equals to 5. We can write it R plus JXL minus 6, where 5 is the integer one and imaginary part 0. So XL equals to XC. Okay, now we have some data. XL, the value of XL is omega L. Omega value is angular frequency 200 into L value is 1 Henry. So 1. So it should be XL value 200. Okay, XL. Now XC we know, X equals to 1 by omega C. Is it okay? So now XC is known to us. So XC is known to us. Okay, XL equals to XC. So it should be XC is nothing but simply 200 because XL equals to XC. So XL is nothing but simply the same as that of XC from this one. Okay, so 200 1 omega is also 200 into C. So C value will be 1 by, right, 200 into 200, or one can write as 1 by 4 into 10 to power minus 4. Yes or no? 1 by 4 into 10 to power minus 4 I am writing here. So 1 by 4, what we are doing, we are multiplying with 100 in both sides, okay, and 10 to power minus 4. So what we can write, this should be 25 into 10 to the minus 6, or you can directly solve this one. C value, okay, C value is 0.25 in 10 to the minus 4. So 25 by 100 into 10 to the minus 4. So it should be 25 into 10 to the minus 6 means 25 microfarad. So our answer for this question, for the, we have to find the capacitor value is 2.24 25 into 10 to the minus 4. XL equals to XC. So we have find the value of XL first. XL equals to XC 200. So X equals to 1 by omega C. And after putting, it will come 25 microfarad. So it can be easy. But this one is the theory, means how we have to find RCLL. So we can write XL and minus J XC. Okay. Then simply we have to write the. So this value is 5. Okay. Because the voltage is 25 ampere, current is 5 ampere, so if overall impedance will be 5. So XL minus XC will be 0, only resistive part will be there. So then we can find the particular value of C for this case will be 25 microfarad that we have find. Okay, so our correct answer for this one will be 25 microfarad. Okay, I am just, our answer will be 25 microfarad. Is it okay? Okay, or we can highlight this one. 25 microfarad is the answer. Okay, so this is all about this question, and this is the GATE 2025 DC question. So the thing is, we have to know the this concept is how to solve or tackle this type of question. Omega is given, everything is given. We can find the value of C, for which the RMS reading of a ammeter is 5 ampere and voltmeter 25 volt. This is all about this numerical. So thank you for watching this video. Thank you.